polar coordinates and graphing. It is going to be super review. It's going to be Algebra 1 review. So it's going to be very quick and easy. The homework's going to be quick and easy. Even the ALEKS is going to be quick and easy. So let's talk about some things that we should know. First off, for the axes, remember the x-axis is horizontal, and it is actually the line y equals 0. So that would be this line right here. The y-axis is vertical, or x equals 0. And that's our line right here. As far as quadrants go, here is our first quadrant, and it goes counterclockwise. So it starts here and goes counterclockwise. As we go through this semester and then eventually into trig, it is really helpful for you to just think counterclockwise for a directional component. It will help your brain as we get through things. For quadrant 1, usually we're going to use a Q and an I. The I stands for the Roman numeral 1. That stands for quadrant 1. Everything in quadrant 1 is positive, both the X and the Y. Over here in quadrant 2, so we started in quadrant 1, we're now in quadrant 2. Quadrant 2, the x's, because we're now going to the left, will be negative, but the y's will be positive. In quadrant 3 down here, both our x and our y will be negative. So remember the Roman numeral for 1, 2, and 3, just use the i's connected 1, 2, and 3. And then the Roman numeral for 4, remember, is IV. If a smaller Roman numeral precedes a larger one, it subtracts from it. That's why it's 1 minus 5 means 4. In the fourth quadrant, the x's are positive. We're still going to the right, but now because we're going down, the y's will be negative. So you probably knew that, but just a little reminder. So here is a type of ALEKS question that they might ask you about the quadrants that you're in. So let's label our points just so that we kind of have something to go with. Let's call this A, B, C, and D. And then I'm going to label it on the actual graph paper that we have in that top right corner. A is the point 0, -6. So remember, we go 0 in the x direction. So we don't go left and right. We just slide down the y-axis to -6. So when it asks you to name the quadrant or axis where the point lies, this would be y-axis. So it's landing on the y-axis. It wouldn't be in a particular quadrant. So sometimes we call anything that lands on the x or y axis quadrantal. It is a quadrant type point. Now let's go to B, -3, 2. So we're going to go 3 to the left and 2 up. And you can see this time we have landed in quadrant 2. And as you can tell, our x was negative, our y is positive, just as we predicted. Let's go on to C. -3, we're going to go 7 to the left and 3 down. And then you can tell that since both x and y were negative, we landed in the third quadrant. And then finally 5, 6. 5, 6, we're going to go 5 to the right and 6 up. And so you can tell that we are in quadrant 1. Okay, so that is something that if you see they have asked you in ALEX how to do that, there's that little drop down triangle, just pick the correct corresponding coordinate or axis. Everybody good there? Okay. Same thing here. It says for this question, this is what you might see in ALEX. What you might see in ALEX there, it says if a point is an x coordinate that's positive and a y coordinate is positive, choose the location. That would be in quadrant 1. And B, the x coordinate is negative and the y coordinate is negative when they're both negative. It's the 3rd quadrant. Okay, sorry about that. Any questions about the quadrants or anything? Okay. Let's talk about a point. Points on the coordinate plane are traditionally going to be called x and y. Remember, your x goes either left or right. Your y's go up or down. So your x's go left or right. The left is negative and the right is positive. Did you see the way I labeled up and down? Ooh, I'm having a day. How about up and down? Up is positive, down is negative. Okay, so now let's take a look at an example. It says, give the location of Paris as an ordered pair. So if we look at where Paris is right here, we're going to go 5 to the left and 5 up. So to the left, we have to designate as a negative. I'm going to call it P for Paris. We went -5, so that's 5 to the left, and +5, that's 5 up. Okay. So some things that are done with coordinates oftentimes are the distance and midpoint formulas. You probably remember those, but let me remind you what those formulas are. The distance formula is derived from the Pythagorean theorem. So that's why you see the square root of, it's kind of like the square root of a squared plus b squared. What's our a? That's our x's, the difference of our x's. So it's going to be x2 minus x1 squared. And then the b squared is the difference in our y's. So that's going to be y2 minus y1 squared. So it's technically, remember, a squared plus b squared equals c squared. The distance could be like our c, and then the difference of our x's and the difference of our y's are our a and our b. Okay. A midpoint formula, please use capital M. We usually reserve lowercase m for slope. So leave lowercase m for slope, uppercase M for midpoint. Midpoint is, think about the halfway point of the x's and the halfway point of the y's. The halfway point between two things is the average of those things. So it is x1 plus x2 divided by 2, half of the x's, or average of the x's, and then average the y. So it's y1 plus y2 squared. Not squared, over 2. x1 plus x2 over 2, and y1 plus y2 over 2. Just the average of the x's. That's your new x. Average of the y's. It's your new y. Now, the instructions down here, and I'm going to do this right here so we have room for it, says to find the distance and midpoint between Paris and Rome. So I'm going to call Rome R. And I'm going to put it right here. And if we want to go to Rome, which wouldn't that be neat? If we wanted to go to Rome, we would need to go 6 to the right and 8 down. So remember, that means 6 would be positive, but the 8 would be negative since we went down. Now, it's a good idea when you are finding distance and midpoint to label your points. So let's call this x1, y1, and x2, y2. No, it doesn't matter which you call the x1, y1 and which you call the x2, y2, as long as you're consistent. So as long as you're consistent in your work, you'll be fine. Okay. So let's do distance. So that is going to be the square root of, now we're going to take x2 minus x1. So x2 is 6, but we are minusing the negative 5. When we minus a negative, it's going to become a positive 5. And then we're going to do the same thing for the y. So it's going to be negative 8 minus 5. So that's going to be 11 squared in the first parenthesis, and then the next one's going to be negative 13. Keep it in parentheses so that you will make sure that it becomes a positive when you do the actual math. 11 squared is 121. 13 squared is 169. Add them together and get 290. Now, Alex may ask you to give that answer as an exact answer. That's the exact answer, square root of 290. 290, like other things that have no perfect squares, can't be reduced. 290 is 29 times 2 times 5, so it's not anything that I can reduce, so just leave it. If it asks you to take it out so many decimal places, just follow the instructions and you may need to put that into a calculator. Now let's do our midpoint formula. This time, remember, we're averaging the x's and we're averaging the y, and averages you add them before you divide by 2. So if we add up the x's, it's negative 5 plus 6 divided by 2. If we add up the y's, it's 5 plus negative 8 divided by 2. And so just, I like for those ones just to leave it fractional if you need to leave it fractional. Negative 5 plus 6 is 1, so that's 1/2. 5 plus negative 8 is negative 3, so that's negative 3/2. If it can reduce, reduce it. If it can't, just leave it a fraction. You will start to see that I use a lot of fractions in this class, because if you go to a calculus class, sometimes the fraction, that exact answer, is more precise, more accessible, easier to work with. So although you may not like fractions, fractions are easier. Why take the extra step to try to put that into a calculator or something like that, or divide? Any questions about distance or midpoint? Are we good with those ones? We good? Okay. So in Alex, it may ask you to do a question like this. See where it says to use the pencil. There's a little pencil tool, and I think at the point of the pencil, there's like a little X that comes along with it. That's going to tell you where you're going to, once you click the mouse or tap the iPad, once it's where it's going to put the point. So if we go to 6, negative 1, just go 6 to the right and negative 1, you would drag that pencil there, and then you would put the point on. So 6 to the right and down 1. So be careful. It doesn't, at least when I've used it on an iPad, it seems as if the point doesn't quite go the way where you think it's going to. So just play around with it. You'll get the idea, and make sure before you hit submit that it's really at the spot you want it to be. Everybody good with that? Okay. So for the remainder of class, I would like you to work on the 2-1 homework. So you might notice that the homework follows the notes. So there are 3 sections of notes we're going to do this week: 2-1, 2-2A, and 2-2B. Tomorrow we'll do 2-2A. The next day we'll do 2-2B. But the remainder of class, when you're done, you are to work on 2 things. You are to work on the homework, where you need to show me as much work as is reasonable for those types of problems. You're going to do the homework, and then if you finish the homework, work on your Alex.